Hello everyone. So today we are going to solve 27th August from the GeeksforGeeks problem. That is the largest rectangle with the column swaps. What the problem is saying is we have given a binary matrix. It means it will only contain zero and ones, and we that size of the matrix can be n cross m, where n is not equal to cannot be equal to m, and that is containing only. And we have can swap any number of times like columns values, and we need to find the maximum area that we can achieve. Okay, so let's go to the whiteboard and see what the problem is saying in detail. Consider this is the input case that we have given. And what will the matrix will look like from this? This will be 0, 1, 0, 1, 0, and 0, 1, 0, 1, 1. This is 1, 1, 0, 1, 0. So as you can see, we can find we can do the any number of the column swaps, and we need to find the maximum area. Maximum area will be defined into length into width, whatever and we have to make sure the area that we are going to cover it up, it will only contain all the number of ones. It will contain that is the condition that we have given. Okay, we cannot take the zeros also in the area calculation. So what does that mean is, consider if I'm taking this uh, section. So it have length of, we can say, like one row and two columns. So area will be 1 into 2, that is 2. Okay, so that is the one possible case. Similarly, here we can say 1 into 2, that area is, or there is no other. Now, if we swap particular column, like consider if I'm swapping this column with this column, so how it will look like? It will look like 0, 1, 1, 0, 0, because this will value will be swapped, and 0, 1, 1, 0, 1, and this will be 1, 1, 1, 0, and 0. Now you can say this is the maximum section that we can take. If we are taking this value, so this is 1. If we are taking this, then it will be 2 into 3 equal to 6. So basically the area of this is 6, and we have to return the area. We don't need to return the which column you are swiping or any other details. We just need to return the maximum area that you can achieve by swiping the columns. Okay. So let's see like what is the problem is saying in detail more, and how we can solve this. Okay. So let's consider we have given the input matrix. Let's rewrite this matrix 0, 1, 0, 1, 0. Okay, 0, 1, 0, 1, 1, 1, 1, 0, 1, 0. So this is the input matrix we have given. Consider I need to find the number of the column swaps. I cannot do like this is a brute force approach. One thing is like you can do starting from the row 0, and you can do like swap this particular column with the any other columns. Like consider this column you are starting it, and first swap this column with this, then find the maximum area of the matrix. Then swap this column with this, swap this column, swap this column, then find the matrix area. Then second, then starting from here, like consider this is the matrix like this only. Now the find the maximum area after swiping every column. So this is the brute force approach. Okay, that is the basic approach that come up to my mind. But the problem is like what we are repeating here is, see that part, like what we are repeating here is consideration of, if I'm taking the complete matrix, I'm starting from here. I need to identify like what is the maximum area that I can take, taking the consideration of the total number of ones. Okay, so that I'm repeating every time to find the maximum area. If I'm swapping 0 with 0, there is no point to swap with that, right? Because it will not going to be give you some result. There will be a point when you are swapping 1 with 0 or 0 with 1 to maximize the area, right? So that is the approach. So consider if I somehow find out like what are the number of ones present at this part, this particular index, and then I can find out easily. So consider if I have given something like that, like consider I found out like the number of ones, like consecutively number of ones present in this particular columns are, I will first write those. So initially this is 0, so there is I will start from the downwards. Okay, so last column is 1, 1, 0, 1, 0. Okay, now this column, this row particularly, so this is 0, there is no consecutive ones, so I will write 0 only. This is 1, and there is another one also, so 1 plus 1, 2. So this what it is saying is there are two number of ones if you are starting from this particular index. So there are two number of ones that is present at the downwards, consecutive number of ones. Okay, this is 0, this we will write as it is. This is 1, so 1 plus 1, 1 plus 1 is 2, and this is 1, so 1 plus 0 is 1. Okay, Now this is 0. This is 1 plus 2. That will become 3. This is 0. So 0 is 0. We cannot do anything. 1 plus 2 is 3. And 0 plus 0 is 0. Okay. So what this matrix is saying? This matrix is saying is you have 0 number of ones consecutively at the downward direction for this particular column. This is saying 3 number of ones present in this column downward direction consecutively. Okay. So as you can see, there are number of 3 ones. Similarly, this is 0 number of ones, this is 3 number of ones, this is 0 ones. And if you're seeing this one, so it will be saying 2 number of ones present at the downward direction. Okay. Now, if we find out the number of ones present at every row, okay, we can find out easily like what will be the maximum area contribution. Like consider if this is the particular row, if I'm taking this is 0, 3, 0, 3, and 0. What this particular row is saying? This row is saying like you have the number of ones present at the downward direction, consecutive number of ones. So if I swap this 3 with 3, then I will get the maximum like area. Okay. But how I will find out? So consider if I sort this array to find out the like in the descending order, so that it will be easy to find out. So what will be the sorted array? This will be 0, 0, 0, 3, and 3. So this will be sorted array. Now this is 0, this is 1, this is 2, this is third index, this is fourth index. Okay, consider my maximum area initially is 0. Okay, this is the area that is maximum area. So this is 0. If I'm starting from here, what it is saying is it means I'm not going to take any contribution. Okay, what it is saying is consider this row particular. What it is saying is consider you have some horizontal bar and there is 0. So this is nothing but this is 0, this is 0, and there is consider this is 3 floor building and this is 3 floor building. What is the maximum area you can achieve from this? Okay, what is the maximum area if you are taking this as a consideration? So if I am taking this, so this will be horizontal should be equal. So it means 0, it will contribute. So if it will contribute 0 and the number of rows, like number of columns, you can say this will be 5. So it will contribute to 0 only, and 0 and maximum area 0 only. Okay. If I'm starting from here, it means I am going to take every particular building of the 0 height only, and I will multiply the number of the buildings. Okay, the number of the buildings into 4, and it is 0 only. So 4 into 0, it will also contribute to 0. For this one, 0 into 3, so it will also contribute 0 only. For this one, now the interesting case is, so now 3. So it means if I'm taking the third 3 floor building as a minimum value, how maximum height will can go? So it will can go for 2 buildings. So 3 into 2, 6. So maximum area will be 6. And for this one, if I am taking this one 3 into and the number of building only 1, so 3 into 1 it is 3, but 3 is less than 6, so maximum area will be 6 only. So like this, so it is nothing but you have to find out the number particular row and sort in the ascending order, and then you can easily find out like what are the number of buildings remaining that is the minimum height with that particular value. Okay, that you can think of. So basically what we are trying to achieve it array of I particular this, if this is array, so we are taking array of index. So what it is, this is array of index, and what are the number of the buildings present. So consider the length is m. Okay, so m minus this particular index, this will be the length, because 5 minus 0, 5 minus 4, this length, 5 minus 2 is this length, 5 minus 3 is this length. So basically m minus I. Okay, so basically if I'm finding for every particular row after sorting in the ascending order, I can easily find out the maximum area. Okay, so hope you will get the approach. So basically there were two things. First thing is you have to do the this matrix computation, re-matrix computation, I would say, for to calculate the number of ones present in the consecutive downward direction. Okay, number of ones basically in the consecutive downward direction. So first thing is you need to find out this. And for every row, you need to sort the particular row. For every row, you need to sort the particular array, and then you can find out like what is the maximum area that you can get it from here. Okay, so these are the two things that you need to do. Okay, so let's see in the code how we will do that. So I'm going to write the Java code. If you're comfortable with it, you can refer that. Otherwise, you can take a reference from here. Okay. So this is n and m I am defining first, and I'm going to change the matrix input matrix only. If we have the best practices, you can create a new matrix and then change it so that like it is a code maintainability for better maintainability of the code. But I'm changing it here the existing matrix only. And so what it is like, I'm just iterating over the matrix for, so this is j equal to 0 to m. And if this particular element is 0. Okay, sorry. So I have to start from n minus 2. Okay, to check I is greater than or equal to 0, minus minus. Okay, if this particular element is 0 only, so I'm not going to do anything. So I'm just continuing. Otherwise, what I will do, I will take the matrix of ij, whatever the sum I have occurred till now, and I will take the further downward direction element of the sum. Okay, that I will do. And this is the recreation of the matrix. Okay, basically recreation of the matrix to find out that particular number of ones. If now we have the number of ones present at that particular area, so particular row. So basically what I will do for every row. Okay, so this is for every row. And now I'm going to sort that particular column. Okay, so consider I will take this column at phi and I will sort this column so that I can easily find out the number of that particular like buildings that are with the minimum height, and consider I have some maximum area of also 0. And what I will do is so now I need to iterate over the column matrix, that is this one. Okay, and now it will contribute to area as math.max. I will take the maximum area, and I will take the that remaining number of the buildings that are m minus j. Okay, because column dot length will be m, so m minus j I will take, and I will take mat of, I would say, column of j only. Yeah, because column mat we have copied into the column, so column of j. Okay, and finally we will return the maximum area. Okay. So this is the regression of the matrix. This part is the calculating the maximum area from each of the column. Okay. So you just have to think like how to think this problem is like you don't need to actually swapping the columns, but what we are going to achieve. Our target is to achieve the largest rectangle of the ones, and how it will come if we are accumulating the number of ones that we are doing it here. And after accumulating the number of ones, if we find out like what is the maximum number of the buildings or maximum number of the ones length we can take, that will contribute to our area. So I am finding the every possible combination from here, and whichever it will contribute, I will return the finally the maximum area. Okay. So let's try with try run. Okay, it is working. Let's do the second example also. This is 4 cross 5, 4 cross 5, and the matrix is 0 1 1 0 0 1 1 1 1 0. Okay, let's see this. Yeah, it is also working. Consider some edge case. Consider you have 1 1 and 1. Yeah, it is working fine. Let's try to submit the problem. Yeah. So hope you understood the problem. Like if you understood the problem, if you learn something new, please like and subscribe my channel. And I'm also creating parallelly a playlist over the tree data structure specifically. I'm going to add more videos. I guess I have added till now 11 videos. So please watch that. I will attach the link. Please refer to that. And if you have any suggestions, please comment over the videos. I will take a look as a feedback. And thank you for watching.